Welcome to the second tutorial on the interplay of Mathematica and Blender for your architectural model. And as in the first tutorial, I think it's not this important that you actually do that. It would be a lot to learn just for beginning. But I think it's important to understand how these things are, and that you can't see an architectural model and you can't structure it. So parametrism or design grammars and so on are not adequate to describe what is going on in the digital with architectural modeling. So to give you an idea how to go towards digital architecture in state-of-the-art languages, I think it's important that you try to follow the argument, the line of argument and notation, and remember that if you go into more elaborated modelings and find certain problems there. So this is what we had in the first tutorial. We had a library of design objects. And they had been, their nature is to do that with CAD, and you are able to see that. This is for your eyes. So then we imported these libraries into the architectural models. Which is neither structure, not geometry, it's code. And it's about writing. And it's about talking, articulation, and so on. And it's to hear. Yeah. So it's with the ear. So whatever it is, simply keep that in mind. That might sound crazy, but I think it helps over a long time. So, and with that, we produced a 3D rendering. It's important that this is done with a ray tracer, and this is an image, and this is to see as well. So it presents them for the eye as well. So that's the turn we introduced. So for this architectural model, we had certain structures or certain functions. So we had the coordinates and so on, and then we had structures. So these is the geometry. These are the structures: 1 to 2, 2 to 3, 5 to 8, and so on. So as long as our architectural model is structures, or we can write algorithms for that, this is fine, and you directly can do that with your code, and then you can have compact forms for that. This is what we see with grammars and with parametrics. So then you can have compact forms for that, and then all this setup works properly. So we had that in the last example. A lot of things are of geometry. So this is a structure or topology. Are of geometry. So there are a lot of points then in space, a lot of connections in space, and there's no systematicity in that. You simply design it. So therefore, it's not about the harmony or the topology of things, but it's about the certain position in space you only can see. So to import that, or to write that in topologies, this is a little tricky and it's awful. So what we now will do is that we call it a master geometry. a master geometry, that we create a master geometry with cat and use that in our architectural model to position design objects in space in a certain way and bring that to rendering. So if we have that, we want to have a very simple setup. So we have a master geometry and we have design objects. So let's go for master. For example, simply take a cube. So, and we have design objects. So which means we create a system that we want to have on this master geometry here a node, and the node, this is normalized. So we say this is, for example, 1 unit. So this is O, this is 1. And then we want to have this element here, a node. We call it node. And it should be of material light gray. And then we want to have an edge. And it should be of dark gray color. So as we did it in our last tutorial. So this should be level of detail 1. And we want to call that library, because we have tutorial 48, it's 48, and it should be on layer 1. This also should be in library 48, but we put it on layer 2. So what we want to have then is that this master geometry is the skeleton for our assembly of design objects. So which means we want to have all these points with nodes and all these edges with our edge element. So these nodes are single objects. These simple objects, the edges, have to be parametrized. So they have to be scalable in length. So we will see how this works, that this works quite fast. So we have 2 inputs, master geometry and design objects. We have our architectural model here in Mathematica. This is code, this is cat. And we want to put that to 3D rendering image. So this is our plan of this tutorial. I prepared a directory 48 with files for Blender and files for Mathematica. So we simply take that and say we make a copy of it and go for 48 and say these are the layouts 48. Save that. So then, for comfort and consistency, not to hustle around with too much files and not to be engaged in a complicated setup, there's this interface from Mathematica to Blender. We worked on that. So simply copy that and put it above your layout. So whatever it is, here we are. Now we have to adapt our structures. This is of a subchapter. So take it and then we say and close this. We don't have to bother with that. And this is our whatever. We will see how this works out. So and do the same with these on meshes. These are a kind of cat functionalities I implemented, which are useful. It's not fully developed, but they are useful for our purpose. So good. So we can skip this and save that. So now what do we want to have? First we have, with the modelings, like in the last tutorial, we have the infrastructure. So this is how this modeling and this system is embedded into the file system and your system of libraries and so on. Then we have the actual layouts in different versions, and this can be organized here. And then we have a machine to export it to Blender. So now it's always a good idea to to modify existing code instead of writing it from scratch, because then you don't forget important things and you follow paths which are useful and turned out to be adequate. So what we see here first is all these symbols. They are blue, which means they are not defined. So do that just by evaluating. And then it says all these functions, for example, create Blender book and so on, they are up here in our libraries. And yes, we want to evaluate that. And now you see they are defined. It's blue, and colored things always means pay attention. So we start with a directory, and now we switch to subdirectory 48. We had different layers here. This is a prototype layer. We keep that. We have an assembly layer. We put that to 1, and we are not too ambitious, so we just stay with 2. Layer A is not defined that. That's fine. Our library should be in the. So this is a Blender file we are working with the design objects. It should be in this directory, and we not to mix up with different versions. We simply say this is 48. This is of this tutorial. So then we discussed that we don't want to have ceiling and columns, but nodes, and we want to have an edge. So, and then in Blender it should work, you can call it node, and of course we want to have level of detail 1, level of detail 1, and this is edge. We also want to have master geometry, and then we say this is master, and we can have multiple of them. So this is master or 1. Our infrastructure is organized like our theater play. We discussed that there can be other metaphors how to organize it. We follow these of the theater play. So first the outline. This is with Blender here, the outliner. We create a block, theme, prototypes on the prototype layer 0. This is fine. So we keep that. We always also want to have the model, or the assembly. So this should be on layer A. Just start with it. So now this is a floor 1. Should be part of assembly, and the moment you have double values here, put it double, you should define it as a variable. So here, for example, now we say, because it's a parent structure in Blender, we say par and then we say model pair assembly is assembly. So now we can, if we define that, now we can take this and we just, you see now it comes up, and here we are. And it's the same here, and then you make less errors. And if it's black, then you know there's a proper name for it. So the same now, this is, for example, we want to have this assembly 01. So we can change it. It's changed then here, and it keeps consistent. And we want to have a separate sub-branches in our outline for the nodes. And we want to have bar assembly. We want to have it for the edges. So these will be the insertion point for all our instances. Therefore, we have to put that as well here. So we say par. So always, if we need a branch in our hierarchy, we ask for par. Node is this, and then par edges is edges. So therefore, we have par. And we have to evaluate that here, and this is par nodes, yes, and this is par edges. Good. So here we say this is layer A and this is layer A. Good. Now this is our outline. The materials, I think we should do it the same. Now, because we need it here as well, and then if we make an error, we won't see it. That's problematic. So therefore, we have a light gray. So it's copy color light gray, and we define it here. Color light gray is this. Color dark gray is dark gray. Dark gray. So, and we say color, and then we have dark gray. So these are the materials, just these two. The meshes, these are our meshes we accept. These are here. Node, edge, and master. This is what we expect. So now, in this logic here, we can take them down and say our meshes got these names. So what we want to import here is the node, the edge, and the master. Good. Now we are fast. And the schemes, we should skip that and make direct copies. We don't work on hierarchies and inheritance. We skip that, I think, for this example. So which means we can do that and close this bracket here, make a semicolon though, and that's our infrastructure. Good. Now the layouts. We want to start with one. We have that. We see there's nearly nothing to do. What we want to have is we don't want to have the instantiate group, but here Blender. So we say create object by matrix. This is what we want to have. Let's look up what it is. We have it here, and this is an example. So close it again and copy it. So what we have. We give it a name. So we say if these are the nodes, so we give it simply an n, and then Blender will automatically count it, and we don't want to have the access to an individual name in our program now. So it should be, this is a mesh, so therefore we have these, let's look in our infrastructure, the meshes. This is not too good. So what we should do is here we say msh node, msh edge, msh master. So if we have that, and now we have it in our system. So which means I can write in here msh, and we want to have the node. So then we ask for the color, and we say a dark gray. And then this is our hierarchy. So we have the parent, and we want to put it to the nodes. So then there's no translation, and here we have it to the layer assembly. So, and that's it. So then we can skip this and put that in the row. Therefore we say what happens if we then go for edge. Then we say msh edge, color light gray, per edges, and layer A. So this should be our layout 1. If we want to export that, we need here layout 1. This is an output, so and this is our output. Whatever it is, I think it's not too important to look at it anymore. But our library is not defined. So now this is the Mathematica code for a test setup whether our things work. So we have this layout. Now what do we need in Blender? We have to create a library, file library 48, and we have to create 3 objects with these names. No, 3 objects with these names, and we have to get 2 colors with these names. So here, this is a new Blender. Now, we go first for the node, go in, and we scale it by 0.5. So now it's a tenth of a unit. So if we go out and look at it, here we see a tenth of a unit. So this is what we wanted to have. So that's simple. What we need is, we say, this is our node object or a prototype. And the reference for importing this is this, and we have to check in Mathematica. This is node LOD 1. Copy, paste. Confirm. So we have it here. We can add an empty object and say these are our prototypes. LOD 1, for example, and then we put the node prototype in here, and then we are here. Switch it off and go for cube for the for the edge. go in, scale it by 0.05, same size. Now we see in x direction it should be 0.9. No, it should be 1 exactly. So we should be 1, but then it's 2 units and we want to have it in 1 unit. So put it on 0.1, and then we have to move it G like this. Now we have to move it centered. That's good. And 1 unit. This is how it is organized. This again is the edge LOD1. Confirm, and this is the edge prototype. And put it to prototypes to organize your library, not your model and your design. It's just a database. So now prototypes. Now we go for models. Mesh, empty here, plain, and these are models or master models. So, and now add a cube. Go in there, and we always put this, cut this, what is this? X, just the faces, then because it's double curved, then fill it and say we want to have the triangulation like this, F for the edge, and then add these, and now F for the faces. Is this proper? Y should be -1. Okay. Good. Mistake. Go. This was named master 01. Copy. And we had that master 01. And that should be in master models. And this is our house A master. Good. It's our library of meshes. Now we need 2 meshes. It was two materials. We have light gray, and we put that to principal BSDF and say this is light gray like this. I'll put it 0.8 around this. Good. And make another one and say this is just copy and paste, because it's important that there's no mismatch of characters. And now we have dark gray and we have light gray. So the dark gray needs will be dark, 0.2. Good. And I think that's it. And we had it as library 48. So file, save as, go to 48, library 48, save Blender. So that's our library. So we already created our or Python file here. So let's have a look. New file, and go and look for it. So we have 48. This is our layout. This looks, so we have load LOD1, assembly 01. Hopefully it works. So, and run. Okay. We have our hierarchies, assembly of edges and nodes. There's always one. This is edge LOD1, this is node LOD1. Prototype I didn't use. So, okay, now let's look in the 3D view. We have this here. So why we have to check this. What is with the material? Yes, we have different colors. So if we go here, we see it's here dark gray, and if we go here, we see we have problems with the light gray, and we have problems with the offset here. So now let's have a look. Assembly edges, they are 2 meters. The edges are 2 meters. It's not our instance, it's the edge which is 2 meters. So, and this is the first problem, so fix it. Edges here, power edges, this is the first problem here. Okay, save it. So the second one, I would suggest we have a problem with our library. File, open recent, library 48. Yeah, okay. I think they don't save it if we don't have addressed a color to a material to an object. So this is to master 1. Let's make it transparent. And we go to, now we have it. We go here. Edge, and give that the number, we want to have that the light gray, so we go for dark and duplicate it and say this is, just copy and paste. Don't make mistakes, it's trouble, always makes trouble. Copy and paste. Return. So then go for a node and put that to dark gray and return that. So if we now master models switch on off this guy, we have that solid model. This is our object here, light gray. Now we have to put it to light. 0.2, no, 0.8. So light gray, good. Get that off. This guy here, if we have the edge prototype, this is light gray, and no, this is dark gray, the node prototype. And this is dark gray. Go here, we have dot 2. So switch them on and save it and try. We have to export again because we changed the edge assembly code. Now here, new, and go for the text editor, have it here, and 48, layout, run it, go back to 3D view, that's okay now here, and we have the assembly, edges, nodes. If the edge is off, we have him. and he is of material dark gray, and we have this thing done. Don't know why it's double, we will see that somewhere. So that's fine. Our system works in a new setup. So the infrastructure works, and we had a test layout. So we can say this is our test. So now open the library. And this is our master geometry. We can export that. What we wanted to have is, I prepared again some Python code to export all our objects. So it's called, cancel. It's called export objects Python. Very short code which exports all the selected objects as OBJ files in a certain orientation, if possible not triangulation, and so on. Triangulation is always done if these the faces are not plane but curved. Then there's triangulation, because triangles are plane then in itself. So if you have then whatever polygon, and if you export that then as flat, then it is not triangulated. So what it says is that we need directory. We call it 48, library 48. It creates a directory. And you will have all the selected objects as single OBJ files in this directory. Very simple. Therefore, we have to go to the file here, go wireframe, select this and this, these three, go to this text, and now we need this library 48. Copy that. Now we are in 48. New library, paste it as a name, and this is our library. Now look what happens. Looks like nothing, but we have our three objects here. Our master geometry is house A master, edge prototype, and node prototype. Okay. Now, get these things done. We have this Blender interface. Now we had that already. Now this, okay. So we say it's a new layout, and let's go. So we say our master geometry is import, and now we can go for this file in our library, library 48, it's house A. That's our master geometry. We want to have an image size 128. So we also can drag and drop this thing into our file. So this is our master geometry. What we can do is here, there's this tool. We can display it in different ways. That's interesting. And we can change the stage. Can have the different perspectives, and we can print it. And we can here now have the vertex positions of the numbers of the vertices, so which is important. So now what we want to do is we want to create a node at vertex number 2. So what we need for that is now first we say we have a graphics from mg is mtp graphics mesh to mesh region to graphics complex of mg. Then we have graphics and can use that. Now we can start with the graphics 3D, and like we did it before, just to visualize our set. So we simply say white opacity, and we say then we take our graphic object, and here we say our stage should be image size, then it should lighting should be neutral, and boxed it should be false. So now this is our object in graphics. So now we can ask mtp mesh. We can then vertex mesh vertex x assembly edge vertex transformation. Okay. MTP vertex transformation of the mesh, the master geometry, and we want to have vertex number 2. And what we get then is a transformation function. It's a matrix which is the translation and rotation to this point. So the idea is that you have this prototypical object produced, and then you bring it to building site and assemble it. So and this is a function of assembly. So this is the assembly function of the vertex, as this. So now we go for the graphics of the vertex. So take this and go here. This is the graphics of vertex. Now let's see, the mesh of vertex. Import, and here we say go for the finder, and we say it's a node prototype. No, I don't want this. Copy. Node prototype obj, image size 64, and this is so it's a little ridiculous. So therefore the graphics would be here, the same thing like that, but from MV. That's the graphics of the vertex. So but I suggest we should say GMV is, just to simplify that, is a sphere of 0.0.0 and the radius of 0.05. So this was our, so this is the graphics of the vertex. So let's structure it so that we don't, so this is here as style subjection. So we say this is, I'll make it, this is a master geometry. And this is the node, respectively the vertex. So now we have this translation function, and we simply want to take this here and assemble our vertex with this function. So we have all this. We simply say gray, keep the opacity, and now we say graphics GT. Okay, make that. Oh, make it explicit. Graphics geometric transformation of. Now we want to have GMV, MV, and we want to have our AV. And that's it. Here we are. Yeah. So now to do it with all the nodes, we simply say, very simple, this is stage 1 with this, and at this, now we say stage 1. Now look for this, and that's beautiful. Now we say AV is not 2 but all. We can have 2 or 3. We can have 2 up to 6. No, that's not working. No, that's not good, but 2 to 3 is working, and we can have all. So keep that secret. But now if we look for stage 1, we have it all. So all the instances are assembled. Now do the same thing with parametric objects, with the edges. Go here for edges, the edges. So import that. No, the transformation. The assembly of the edges. That's the MTP edge transformation, MG. Now let's look here, go here and say we want to see not the vertices but the edges. For example, take edge number 1, that's the diagonal here. Okay. So X number 1, and here we need an offset. So because our node is radius of 0.05, we need an offset of 0.05. So, but I think we should give it 0.1 offset left and right. So now we get a transformation function. This is in 2 steps. First step is the scaling. So which is the parameter in length. So this is the scaling, because the diagonal is longer than 1. And then the assembly. Yeah. So go here and now do similar things with, now we need the profile. We have to import that. This is the module here, and we have the edge prototype, though we have it here. This is our thing. I think we should have this on 0.1. Good. Yeah. So this is again, it's always very schematic. So now we need the graphics for that. So this is on E, and we have it E, it's here, very simple. And now we can take stage 1, but make a stage 2 of it. Stage 2. Say stage 2. Now and now we introduce our element here, and this is for the vertex. And now we say we can keep the gray, and then we say geometric transformation of GME, and now we need a dot product of the two vertices. So we see what we have here. That's these are the two transformation functions. If we make dot of AI, then we put it into 1. So you see the multiplication of these two values and so crisscross. So therefore, if we want to have the production end in 1, we put that here, and that's it. Good. Now, if we want to do it with all of them, it's very simple. So and that's the beauty and the strength of Mathematica. Simply say again all, and now we have to change our. So we say AR is a list. That's a little tricky. So it's a list here, and then we have to put that to 3, then it's fine. Put that to 3 as well, and now it's open for this format. And now if we stage that, look it up why it is like that. We are here with our element. So that's cool. So this is a kind of lab, yeah. So to get these functions and so on. Now we want to bring that to Blender. So which means we have to, this is the master geometry and so on. So now we have to put that into 1. So what we only need is, we need the master geometry and this. Yes. So we don't need the graphics here. We need the AV. This is the assembly of the vertices. We need the assembly. This is just to make the renderings in Mathematica. Therefore we need the graphics and so on. So AV, all. So now we have to put, yeah. No, we need the MGs. MG, all. And here, AV all. No, E all. Here, this is one. Just that. Now we get all the transformations. Now we need our layout. Layout 2. So, and now we have, very simple, we simply need, these are the nodes. These are the transformation functions of the nodes. So we have to simply take this here and run this on a V. All the elements of a V should each element of a V should create a node. So the same here. The dot of this of all AE. That's it. So let's look it up. Put it here. And that's our code for doing it. The rest is just the lab to explain how it works to do graphic computation in Mathematica and its rendering and so on. If you want to have better rendering of the results, this is pretty good already, then go for this interface to Blender. So if we run that, we have some things. We can look it up, but let's wait. We switch here on layout 2 and bring it to Python, which is simply a reload, the same procedure like always, and go for the layout. And here we see this thing. Not possible to do that by hand. So yeah, therefore you see it's a geometrical master geometry, and it's complicated to do that with code or parameters and so on. It's good to have that. And so, for example, the parameter of a building or of your ground and so on. Take that as geometry, and then you're there. So run the script, and here we are. Look at this. Yeah. So we made a mistake with this with this element in the library. This should be bigger. We can do it here, but it would be bad. So we can go for the library. Library. Open library Blender. Here. Then go for the node. Go in. Scale it by factor 2, leave it, save it, and now you see what happens if we can keep all the architectural thing. Now if we open or cancel, if we create a new object and open our code, layout, run that, go to 3D view, then we are in a proper setup. And we have it with nice material. That's it. So let's make a more, now we have a machine for that. Whatever master geometry we have, we can create this kind of production for example, if you want to have a principal facade for a certain company, then you give the mesh and then you get the facade, whatever mesh you have. So let's play with that. Make a new project, simply a new master geometry. So, and play with that, and you see we don't have to do anything anymore. So we have a mesh plane, go in, scale it by 6. Scale it by 2, and scale it by 4. t. In y it should be 0.5. That's good. Okay, don't make, you just have to get the idea. So now we subdivide that and make a mesh as we like. So we can make any drawing, because now this is with the eye, and this is with geometry. This is analytics, topology, and so on. So subdivide, keep that leave, take this tool, that's proper for us, or propose. Have that, and then say we want to have 16 subdivisions in this direction, and we want to have 4, 6 in this direction, something like that. It doesn't matter. So, no. I want to have a loop cut here, and I want to have a center line, so this is good. Oops. No? What is this? Loop cut. Okay. Okay, now deform it. This might be a conventional facade, so no problem, but now deform it, because our model gets parametric. Huh? So go for these nodes and move them up. And now we have these tools. Go for no. This is not too good. Okay. Let's start again. So okay, now make another master geometry. We start with a plain Blender file, and create a plane, scale it by let's go 6. Go here and say, and here it should be just 4. So we have this kind of element. Nope. We have to go inside and then scale by 12, and have that with 6 or 4. Good. Now subdivide that. Proper way is this tool. Go for okay. Now subdivide it in this direction, and say, for example, 24, which is good. Now we select these center elements, move them up. Okay, and we enable this proportional editing, and here you see what happens. I don't know why this is working like this. Make it proportional here, move it up. and yeah, here we are. So we get it like this. Cool. Good. Whatever it is. Good. Now we have this. We can go here and say A, B, and B, and zoom that to 0. Scale Z0. So we have this. Yeah, this is okay. Funny. So we don't want to win a prize with that. Leave that, and this is our mesh 1. So we can select that and go and export. This is what this Python function is doing, but because we have only one, then we go for our library here and we say this is our grid, and we have to check it here. Forward should be Y, otherwise we get a mismatch in orientation with Mathematica. No, include yes. No, include right materials. No, then no triangulation. Object as object. Only the selected. So this is what we did with the Python code for each object. Good. Save that. Now go to Mathematica. And the only thing what we have to do is we have to go here. No, let's go for this is. We take this one here and we put it as layout 3. And we simply have to change this to grid. Dot object. And we simply trust our machine that this will work. So we have that. Now it's calculating all these nodes and edges. It's quite a lot. Okay. Now export this code, and here we are. This is now layout Python, and we can go in here, go to text editor, open library layout. Here we are, all these nodes. It's a lot. Run that, and here we are. 3D view, and this is our calculated thing. So we can render that, so we go with material, that's proper. Then because it's now assembled, we can move it up with the whole thing. Now we put a plane, ground, scale it by 12, give that plane a color. Good. Scale it a little more. Good. We have that. Display, we don't want to have this these relationship things. We don't want to have the grid floor, so that's it. Now we add a sun. The sun, put that on 20. Go sun, put 5 like always, and 3. Now we have the rendering. It's here. And because it's structured now, we can go for any of these edges, because they have all the same edge here. Then we can go here for the material. This is light gray. We can add a material, and we say this is gold. And go here for color, for the edges, and give that metallic. And we do the same with the nodes. Go here for the nodes. They have dark gray. Duplicate that and say this is aubergine, and give that aubergine, and make that metallic as well. And here we are, with a proper organization of our mesh. That's it. I hope you got the idea how these things work. That's it. I hope you got an idea how these things work, and we will have further discussions, I think, in the 4th semester. So thanks for watching. I hope you got an idea of what architectural modeling is, and that you can play around with the interplay of structures and forms and crisscross, and with code it gets super compact. Imagine these kind of things. You simply draw that, and you have all control with a structure like this. So it's nearly nothing. So, and of course you can do these things in Blender. You have, for example, these modifiers and so on. But to do that, somehow this is the end. So it's getting complicated. To have the result in a structured way like this is impossible. Of course you can program that in Python, and if you're masterful there, it will work. But this is where Mathematica starts. And you see, this is the elegance. Just put it in, and then instead of one, you have all, the whole thing, thousands of things, if you like, all in the same way. So, therefore, I think this orthogonality of graphics, which is for the eye, and code, which is the talking, which is for the it's a writing, and the talking, it's with characters, it's staging, and this is for the ear. So. And whatever, it's interesting to make this comparison and this art of categorization. But our screenplay starts here. So because we are not buzzing around with the eye, we are just writing able to write our poems, whatever it means for the eye, because that's in a structured way to the CAD system and to the modules as well. And then you see we don't hustle around here just for making pictures and optimizing these things. So we are not interested, because it's just a rendering of our code, an unfolding of our code. So and then in our in our library, things are extremely simple to organize and to draw. So we at no place we get towards the limits of what we can do, which always means we have the proper arrangement of tools to do our things without hustling around. Thanks for watching. See you with the next tutorial, which will be simpler again. Thanks.